Our next presentation in this first section will be presented by our colleague, Dr. Wanda Markotter from the University of Pretoria. And we're not only going to talk about rabies, the disease, and has been mentioned, rabies virus, as we know, is the type species of the genus and the most important one in regards to burden. But I'm hoping that she will be also to enlighten us about other agents within this genus that also all cause the disease.
So I'm really going to talk a little bit about some of the other viruses that's not causing our major public health concern. And then I will end off with what's going on in South Africa in terms of canine rabies, and just a few comments on that. But I'm really going to talk about what I do. My research is focused on bat pathogens, and we do a lot of work on the rabies-related lyssaviruses. And I don't know if you've seen the diagram of the virus today, but I actually wanted to highlight something on this slide that's recently changed. And the names and the subfamily of where we now fit lyssaviruses in is different. So there's now a subfamily under the family Rhabdoviridae, which is now called the Alpha Rhabdoviridae. And this is a group of viruses infecting vertebrates, non-vertebrate hosts, and sometimes both of them. So it's really a little bit different from what it was. There was never a subfamily. And then the lyssaviruses is in this. And in the lyssaviruses, we have a very high diversity that Dr. Ruprecht referred to. And I'm just going to show this slide to show, through the years, you've all heard a lot about the prototype virus, rabies virus. And in the developing world, this is the virus that's causing all our canine cases. And we still, our major public burden is because of this virus. But then we have this whole diversity that can all cause the disease rabies. There's not always a lot of human cases. You will see very few of them have spilled over into humans. And they've got all kinds of names, as you can see here. And then I've actually put the new names for you in brackets, just to confuse us all. So European bat lyssavirus, for instance, is now lyssavirus Hamburg. Some of the African ones, Lagos, Makola, and Divanoche, at least the names are the same. Australian is Australis. And then some of the others where there's been some name changes that you can just take note of if you see these funny names. And currently, ICTV recognized 17 different lyssaviruses, and that's rabies, and then all the rabies-related ones. And then Cotalati bat virus is in the process of being recognized. And I'm going to tell you about the two new ones that I've mentioned here at the bottom. They've got very distinct geographical locations, as you can see here on the map. Some of them only occur in Africa, some of them only in Europe, some of them only in Australia. So they seem to have a very distinct geographical and sometimes even bat species niche. Most of them are associated with bat species. With here and there, we're not exactly sure what the reservoir are. So I'm going to talk a little bit about what we've done in South Africa over several years. It's probably now getting close to 15 years. We've done routine surveillance in sentinel sites where we also look at other bat pathogens. So this is not just the rabies program. We're just also looking at lyssaviruses in bats. And we've done surveillance at these sites through the years. We also work very closely with the national museums because, as you may be aware, rabies is a neurotropic disease. So the organ where you will find the virus is the brain. So if you really want to find the virus, you're going to need a dead bat. And we don't go out and kill bats for this purpose. We work with other people and have sort of a passive surveillance system where we take vouchers from the museum. We get all the carcasses of bats that goes to our rabies diagnostic national reference labs, and then also from bat researchers as they count them. And then we've got some opportunistic sampling events. And what we actually also get a lot of submissions from is from bat rehab groups. We've got a very active bat rehab community in South Africa, and they actually the ones getting in contact mostly with sick bats that are then either euthanized or they die, and we then test them. So we really do everything when we go out into the field, because this is a really multi-interdisciplinary program where we collect all kinds of samples. And on top of that, we do it over seasons. We do longitudinal surveillance so we can actually look at sero responses over time. But we also try and track our bats so that we can see if we recatch a bat, what happened to the serology, and also in terms of other pathogens shedding, what happens over time. And we use the tooing and pit tags. What's also quite very strong in our programs is the taxonomy of the species. So we work very closely with museums and make sure we're always correct in identifying our bats, also using molecular methods. So this is something that we've really invested in over the years in South Africa. And then just to show you the whole program, we don't stop there. We really go out to the community and explain to them how to live safely with bats, so that bats are not feared because of rabies and other diseases, but that they really understand that they're important and they can live safely with them in their environment. So getting into more of the research, so if we deal with Africa, for instance, we have a large diversity of bat species, which include fruit eating as well as insectivorous. We don't have vampire bats on the African continent. And if we come down to Southern Africa, we're getting to about 130 species of bats, so high diversity. So we really need to understand species diversity. We need to understand the ecology if we want to look at risk of bat diseases, including rabies-related lyssaviruses. So this is one of my recent summaries of what we've done over the years in South Africa since 2004. And this is just brain samples that we've collected from bats opportunistically because we had to take vouchers for other reasons. It includes the fruit bats, Rosetta egyptiacus, that we do a lot of experimental work with. That's why we have so many vouchers. And we've tested over 1,170 brains throughout the 16 years of 41 different species in Southern Africa. There's a few that we're not sure about the species, so that's why I say a few unknowns that I haven't included, but that's only a few. And throughout all these years, we only had 11 positive bat brains. So most of these bats are actually healthy. It's really a very small percentage that has active lyssavirus infection, in this case in the brain material. So I wanted to just show you what we found. So one of the viruses that's very unique to Africa is Lagos bat virus. We haven't seen any human cases of this, but what I have to note is when we went back to retrospective samples in our veterinary labs, we did find spillover infections in cats and dogs, and even in a mongoose. So that just highlights that we shouldn't forget about these rabies-related lyssaviruses. They all spill over to domestic animals, they all spill over to wildlife. And there's been very good examples in the US where rabies virus from bats actually established in carnivores, and there's still active cycles of that spillover happening. We have to recognize that the vaccines don't protect against all of these. So it's really something we need to watch. These viruses may occupy a niche where they may become a problem in wildlife and then also in spillover to humans or domestic animals. So that's the reasoning behind why we need to understand this diversity. It's not just for research purposes. So Lagos bat was always in South Africa, and this specific bat that you can see in the purple, Epimetheus valbergi, lives in between people. And it's really all over KwaZulu-Natal, and we always get 1 or 2 every year that's positive. But when we started expanding our research in South Africa to some of the other fruit bats, Rosettas, we also found it in that bat. And this was no surprise because some of the previous work I actually did with Dr. Ruprecht and CDC, we did find this virus in the specific species in Kenya. And we can see the genetic diversity groups with specific bat species, indicating that it's not just geographical, but it's also linked to specific bat species. This I'm just going to show you very quickly, but it's probably blue, shows where we've detected the viruses. So the areas that's not indicated just means we don't have very good surveillance. Some countries just don't look for lyssaviruses at all. If you look at serology, there's several species that can be implicated in lyssavirus infection, and we need to be cautious with serology, but it gives us an idea of exposure of lyssaviruses to bats. The other virus that we get in South Africa is Divenage, and this virus actually caused human deaths. Only 3, but it caused human deaths in the past because of somebody having contact with a bat. And we were always unsure what virus species or what bat species is associated. And this bat at the bottom is Miniopterus species. And people always said it's Miniopterus, it's Miniopterus, it's Miniopterus. And there was no evidence. And we again found this bat in this long-eared slit-faced bat in South Africa. So we're pretty sure it's not Minihopteris host. It is actually Nycteris thebaika, as was also indicated in Zimbabwe. During our Duvenage work, we identified a new bat virus that we consider new, but it's still up for debate, that we called mudglue bat virus. If we did the full genome of this virus, and this was actually from Minihopteris species. If you look in a phylogenetic tree, it's the most closely related to West Caucasian bat virus that was only previously identified in Eurasia and never on the African continent. But it's just on this brink of deciding genetically if it's a new lyssavirus species or not. So it's about just over 80% similarity, and I will show you where this fits into taxonomy. If you look at important pathogenic domains, it looks very closely the same as West Caucasian bat virus. So there's not really things jumping out that looks very different. If we do some predictions on antigenicity, we see it forms a completely different antigenetic group. And if you look at this picture, it's actually, now I can't see 5 minutes, so I must actually go very quickly. It's actually a complete antigenic group on its own. So the bat species are actually very different. You've got the one in South Africa, the other one in Eurasia, so they don't overlap. So that's why we also say it's a new virus. And then I just want to show you something interesting that we recently found. We found a new virus that's Hamburg-like. It's very closely related to European bat lyssavirus. It's more than 20% different. We also have the full genome and in a completely new bat species that occur all over Africa. It's actually one of the well-known serotine bats. So this is a new virus that we found, and the pathogenic domains actually look very different from EBLV1, which is the most closely related virus. So if you look at new viruses, yes, on genetics, the one looks just on the brink of being a new virus, the other one not, but they do have very specific ecological niches and host species association. That's also being considered if you look for a new virus. So then I want to get to canine rabies, which is the important discussion today, and just showing basically a few very worrying things from South Africa. So I'm on the rabies advisory group for the country, and we recently summarized all our rabies data for the past few years, also including molecular epidemiology data. And if you look at this graph, we're actually in a state where we have the highest number of rabies cases in South Africa reported since 1928. You will see there was these very nice dips where we got dark rabies actually under control, and that was because we were vaccinating. And the reason why we're seeing these spikes is basically a lack of vaccination currently in South Africa. Our highest burden is still in our KwaZulu-Natal province, but we also have a high burden in the Eastern Cape, and it's currently reflected in a very high amount. Usually we have very few rabies cases in humans per year. If you look at this, we already have 21 last year, confirmed from January. This is actually from 2022, not 2021. And we have 2 huge outbreaks at the moment in the country that's bigger than ever before. We do see the same trend. It is driven by dark cycles, and as soon as we see dark cycles, we see spillover into some other livestock and also domestic animals. And it's really about ongoing vaccine campaigns. If you look at our success stories where we got human rabies in KwaZulu-Natal down to 0, and look where we are again now, just because we didn't continue with vaccination campaigns in animals. I'll end off with how complicated some of our cycles in South Africa are. So we have these dark cycles in our 2 provinces here at the coast. And then we also have our wildlife cycles. So we've got a bat-eared fox in the yellow, we've got a dark jackal cycle in the blue, and we've got mongoose cycles. So we do have these wildlife cycles, and re-looking at some of our epidemiology data, molecular epidemiology, some of these wildlife dark cycles are actually linked. So if we don't vaccinate in dogs, there may be spillover from the wildlife side also if we do get to the point where we eliminate rabies. So I think I will skip that and just leave you with a few reflections on how important it is to keep on vaccinating. Don't think it's going to disappear forever. And that we really need to look at the epidemiology to also look at how we can effectively implement vaccination campaigns. We've showed in South Africa that we don't need to get to 70% if we're clever. We just need to do our barriers where we know the disease are coming from, and we actually have molecular sequencing data to assist us in making those decisions. Thank you. That was very rushed, but that's how I'm going to end.
Excellent. Thank you very much. I'd like to ask, given your last point in reflections and that interface between domestic animal rabies as well as wildlife, given what we think we understand of the complexity of rabies in Southern Africa, do you feel that if you're able to achieve effective routine dog vaccination, that canine rabies will be eliminated? Or what is the importance of wildlife and wildlife rabies, particularly in the canids, either serving as an incidental or as a maintenance host that might bring dog rabies back, either from the perspective of Southern Africa or from the standpoint of the continent as a whole?
Yes, I think if we look at some of our molecular data, there's some of these cycles that's shared. And it's becoming more and more clear the more we do sequencing and we look at the full picture, especially between our dog jackal cycle. And then it actually drives, because the jackals move further. So if there's spillover, the jackals take it even into a new area where you may not have ring vaccinated. And that's my opinion. We're still trying to prove this with sequencing data, but one of my postdocs are currently looking at all of this. And it becomes more and more clear that there's something going on between our wildlife and dog cycles. So yes, if you have a small area and you ring vaccinate the dogs and you know your wildlife are not going to move far, maybe you will be successful. But if you have something like a jackal that runs everywhere, they even bring rabies into the Gauteng area in South Africa, then you need to vaccinate the whole country and to really keep that vaccination up. So it's really, I think we need to not forget about wildlife, and we need to really understand using molecular epidemiology and enough sampling of wildlife positive rabies cases to understand that, because we sometimes only see results from the dog cases and not enough from the wildlife. My opinion, some people might dispute this, but it's my opinion.
So given that point, should we see wildlife as a handicap to begin dog vaccination, given that we can't eradicate rabies, we can control, prevent, and selectively eliminate certain variants? Should we use that as an excuse not to begin the ZBT?
No, because I do think dogs is our major contact point with humans. So if we do make sure dogs are vaccinated, we will probably bring deaths in humans down. But it will be reintroduced if we don't keep on looking at the situation, in my opinion. But at the moment, it's vaccinating dogs. I always say we can have very fancy plans, and South Africa has fancy plans, and look where we are. We need to get vaccines into dogs, even if it's 20% or 30%, but it needs to happen, and it needs to happen continuously.
Excellent, thank you.